Hello students, now we are doing the chapter Oscillation. In this we are doing the numerical part now. We are having HSC textbook page number 129, sum number 8, unsolved problem. What we are having here is at what distance from the mean position is the speed of the particle performing SHM half its maximum speed given path length of SHM is 10 centimeter. So what is given to you is your given is, always we write given. The path length is basically it is the distance between the 2 points. Suppose for example we are having this is the mean position and M are the extreme position. We are having minus A is the amplitude in left hand side and plus A is the amplitude on the right hand side. Displacement of particle is given by x from its mean position. So what is your path length is basically entire this, it is from left extreme to right extreme. So that is called as a path length. So distance between N and M. So your path length is given as, the particle is performing linear SHM, the path length right from N to M, right from left extreme to right extreme, it is your path length given by 10 centimeter. So we can write it as twice of A, that is 10, and then A is 5 centimeter. So we are getting amplitude from here, that is A is 5 centimeter. At what distance from the mean position, at what distance, suppose the distance is x from the mean position, is the speed of the particle performing SHM half its maximum speed. One more thing they have given here is, they have given is the speed is half the maximum speed. V is V max upon 2 at what distance? So you have to find x at what distance. Here I am writing when V is velocity at that point, at that distance is V max by 2. What is the solution of this? We are having formula for V is given as V max upon 2, which is given to you. What is the formula for V? Velocity. At any point in terms of x, we write V equal to under root of A square minus x square. So we write basically it as A square minus x square, formula for velocity at any point in terms of x. And here it is already V maximum. We should know what is the V maximum. So always velocity is maximum at the mean position, that is given by omega A. So V max is omega A divided by 2. So V is at omega root of A square minus x square equal to V omega A upon 2. Omega will get cut. We are going to get A square minus x square, and then we are having your A by 2. Squaring on both the sides. We are having A square minus x square, that is A square by 4. We will have x square is A square minus A square by 4. Then again this x square is going on right hand side becomes positive. Then we are having x square is, we are having 4A square minus A square is 3A square. 3A square by 4, and as it is we are getting x is under root 3 A square root of this is A by 2. So root 3 upon 2A. At what distance from the mean position? The distance we are getting is x. When V equal to V max, we are getting the answer as x is root 3 upon 2 into amplitude. So this is the answer. Okay. So what is your amplitude given as? X is having root 3 upon 2 into amplitude. So when we keep this formula for amplitude here, it is 5 centimeter. So we have to solve this. Your root 3 is 1.702 divided by 2 into 5. So answer we are going to get So you solve this, students. We'll get the answer as here 4.33 centimeter, which is given in your textbook. So the answer is going to match. Students, we are having sum number 9, page 130. In SI units, the differential equation of an SHM is d square x by dt square is equal to minus 36x. Find its frequency and time period. What is given to you is directly we have to find. This is given, we can write find to find its frequency, that is n, and then we are having to find its time period t. Solution given is this: d square x by dt square is minus 36x. We can compare with this differential equation. We are having comparing with differential equation of linear simple harmonic motion. So we are having formula d square x by dt square is minus omega square x. Very easy sum. To compare this with what is given to you, therefore we are having omega square 36, omega is 6. So it is radian per second. Moreover, we are having what is omega? 2 pi n. So what is your n? N is omega upon 2 pi. So n will become, what is omega? Omega is given 6. 6 upon 2 pi. We'll give you the answer, that is in hertz. Please solve this. Similarly, we can find time period. There is a relation between your time period t is 1 upon n, t is 1 upon n. Put the answer of t and find out your seconds. So, please solve this. Frequency is 0.955 hertz. You will get t is 1 upon 0.955. With the help of log you can calculate, and this is with the help of reciprocal of time period. You will get the reciprocal of time period is 1.05 second. So this is the answer which is given to you. Okay, it is the correct answer. Please solve this by log, and this we can find reciprocal with the help of log table. Students, now sum number 10. A needle of sewing machine moves along a path of amplitude 4 cm with frequency 5 Hz. I have given amplitude is 4 cm and frequency is given to you 5 Hz. To find its acceleration, A or AC you can write. To find acceleration after, find its acceleration after 1/30th second crossing the mean position. Find its acceleration 1/30th second after it has crossed the mean position. After 1/30th second crossing the mean position. So what will be the acceleration? So initially what we do, we can use the formula. Acceleration is omega square x, or acceleration maximum is omega square a, but at any point acceleration is omega square x, and x is crossing the mean position, x is a sin omega t plus pi, but instead of x is a sin omega t plus pi, we take x is a sin omega t. So the requirement is omega. We should know where is omega. Omega is not given to you, but omega we can find. So here the first thing is we are finding is omega. Omega is we are having 2 pi n, that is 2 pi into frequency is given to you. Frequency is 5, so we are having it is 10 pi. We are having radian per second, the units. And then we can use the formula for acceleration. We are having formula for acceleration is omega square x, but at mean position, particle starts crossing the mean position. After crossing the mean position, we can find acceleration is omega square x. So we write omega square, and x is nothing, we are having a sine omega t. A sine omega t plus pi. Pi will be 0 because after crossing the mean position, then we put the value acceleration is omega square. So just put the value omega square. We are having 10 pi the whole square. Amplitude is given to you, that is 4 centimeter. We'll go in CGS, and sine of omega. Omega is again we are having 10 pi into time. Omega is 10 pi radian. So directly we are putting the value into time, and time is how much? After 1 upon 30th second crossing the mean position. So 1 upon 30th second. So if you are going to solve this, you will get 10 pi the whole square. It is, you will get somewhere 100 into 3.14 whole square, or 3.142. We'll take 4 into sine. We are getting 0, 0 will get cut. We are getting pi by 3. So if you solve this, you get acceleration which is, that is 3.14 square into 4 to sine of, this is basically sine 180 upon 3, that is sine 60. Put the value of sine 60 from the logbook. So the answer we are getting here for acceleration is 3420 centimeter per second square, as we have taken amplitude in centimeter, and finally you can just convert it as 34.2 meter per second square dividing by 100 in meter per second square. Sum number 13 is a simple pendulum performs SHM of time period 4 seconds. How much time after crossing mean position will be the displacement of the bob be 1/3 of its amplitude? So displacement of the bob is 1/3 of its amplitude. Given is simple pendulum is performing SHM, time period T is 4 seconds. So time period is T. They want to find they are having time taken. How much time it will take after crossing the mean position, the center position, that is, it is oscillating after crossing the mean position. How much time it is going to take? Will the displacement, when given is when displacement x is 1/3 of amplitude, it is given to you. So formula, that is after crossing mean position, we can take the formula. So for mean position we are having, after crossing mean position, or from mean position, the formula for displacement we write it as x is a sine omega t plus pi, but we write x is omega t, a sine omega t. Pi is 0 because after crossing mean position. So for mean position it is modified to x is a sine omega t. What we are having is, it is given when x is 1/3, so here we write it is 1/3 1/3a, that is amplitude, then sine of omega. Omega, we are knowing omega is nothing, it is 2 pi by capital T. This is what we know, relation of omega is 2 pi by T, or T is 2 pi upon omega. Into time we have to find. So we are going to find time for this. Moreover, when we solve this, we get sine of 2 pi upon time period T, it is 4 into T, we get it as 1/3. Again sine, we write pi by 2 into t, which is 1 upon 3 is 0. We will solve it, we will get 0.333. Okay, so we are going to get 0.3333, it will go on. Okay, so 1 by 3 if you will divide. Here we are having, we write basically pi by 2 t sine inverse, it will go on that side, it will become inverse of 0.333. So this basically value is in radian because we want answer in degrees. We want answer in second, that is t is, we want the answer for time, what time it is going to take. But here we are having in a logbook, we are having sine inverse is in degree and this is we are having in radian. So what we will do is we can convert this into radian. Okay, so first we will find out pi upon 2, we are having t is sine inverse. Now this is in degree. So what you can do here it is, I'm just writing here t is 2 upon pi. To convert this into degree, what I will do it is pi by 180. So this will become in degree. And what is sine inverse? 0.33. This factor, if we are going to convert into degree, we are going to get somewhere about, if you see in the logbook, we will get 19.45. Approximately 19.45 degree. Pi will get cut. So if you are going to solve this, you can check. You get 0.2163 or 61 seconds. Number 17, we are having a particle performing linear SHM of period 2 pi second about mean position O. About mean position O is observed to have a speed of b root 3 meter per second. When at a distance b meter from O, if the particle is moving away from O at that instant, find the time required by the particle to travel further distance b. The meaning is, suppose I will deal with solution. What you have to find, I will tell you. Here we are having what is given to you. Just see from the diagram. This is the mean position we are having. These are the extreme position N and M. On both the sides. We are having minus amplitude. We are having plus amplitude. Particle performing SHM of time period is given to you 2 pi second. So given to you is t is time period, which is 2 pi second. To have a speed of, so about me is observed to have a speed of b root. So speed is your b root of 3 meter per second, that is when at a distance b meter from O. So at distance b meter from O. So at distance b from O. So here in diagram from O, so you are having at this particular point, suppose let us see, suppose this is my b. Example, this is point, this is b, at a distance b, your speed is your v, at this v is your b root 3. So b root 3 is given at particular point is, that is from O. So distance is x, that is from here it is, the distance x equal to b, when x is equal to b, so velocity at this point is b root 3. If the particle is moving away from O at instant, find the time required. So let us take this as time t1, and if the particle is moving in the same direction but travel the further distance b. So if it is going to travel the same distance b, suppose it is going to travel the same distance b here, so that time will be t2. So at what time it is going to travel the same distance b? You just see. So basically you are going to find is time taken, that is time taken t2 minus t1. Solution. What will be the time taken to travel, required by the particle to travel further distance b? So it is basically the time t2 and t1. First we will see what is my further distance b I will get. It means if this is b, the double is we are having 2b. So twice of b we are going to get somewhere. So at this point we are going to get twice of b. So you are going to see this is nothing, it will be the displacement x from the mean position. Let us solve this. Okay, now first thing is you are going to find out, we required here time, we having formula for x is a sin omega t for starting from mean position, x is a sin omega t, and then for x is a sin amplitude, we require amplitude, sine of omega t, we need omega there. Okay, a sin omega t where t plus pi, that is x is a sin omega t, then we can find formula for velocity, we are having v, and the requirement for velocity again it will be in terms of from mean position with respect to time, it is a omega cos omega t, and then we should have a omega. So again omega is a factor here. So let us find first factor omega. So let us go for the formula for first to find factor omega. What is omega we are having? Omega is 2 pi by t. So if you are going to find omega is 2 pi by t, what is your time period is given by 2 pi. So if you will solve this, you will get it is 1 radian per second. So here we are getting your omega, that is 1 radian per second. More further, as we will go more further, let us use the formula. Next is we are going to find the amplitude, since the amplitude will be required to use in the formula for x. Displacement x is a sin omega t, and for velocity v is a omega cos omega t, and finally t2 minus t1. So we are using a formula is v, which is equal to omega under root of a square minus x square. Now when v is here at, suppose at this point I am taking b root 3, it is omega is 1, we are having amplitude is, what is amplitude we will just find from here, and x. Now at this point what is your x? So now what is going to happen is you are finding x for this point. Now your x for till here, you know what is displacement. So from here to here, what is the x is your b. So here I am getting x as b. Why x is equal to b? Because so here we are adding at x equal to b, we are having velocity is b root 3. So when your x is b, when displacement is b, when particle is at this point b, so velocity is b root 3, which is given first part. So when we calculate this, so here we are getting is squaring on both the side is b square into 3, 3b square will get, that is equal to a square minus b square. Squaring on both the side, a square which is 4b square and a is 2b. So we are getting amplitude here, we got omega is 1 radian per second, then we got amplitude is twice of b. So now we came to know what is amplitude, the maximum displacement is amplitude. So right from here to here, the amplitude, right from here to here we are having this part is nothing, it is 2b. So the amplitude which we are having, it is nothing, it is 2b. 2b is your amplitude, maximum part. Okay, we got this amplitude. Now let us go more further. We'll use the formula for velocity again with respect to time. Why we are using this formula? It is omega a cos of omega t with respect to time when particle starts from mean position. Already we have proved this with respect to time, omega a cos of omega t, because here now we are finding velocity, we are finding, that is we are finding at t1. So when t equal to t1, so at this point when particle moves from here to here, so already we are knowing what is velocity is b root 3. Amplitude we got from here. So at this, from here to here, what is the time from here to here? So what is the time taken? So when t equal to t1, we are having the formula for velocity. How much is the velocity here we are having is b root 3. So b root 3, which is equal to omega is 1, that is into 2b. Amplitude we got. This amplitude we are having, you can write it as meter. It is in meter, because meter per second is given. So 2b, we are having then cos of omega. Omega is again 1 into t1, so that is cos of t1. Okay, so omega is 1 we are having, and then t is t1, cos omega t1. Okay, so from this now we will solve this. We will get cos of time t1, which is, if you solve this, is b root 3 divided by 2b, so we will get root 3 by 2. Then t1 will be equal to cos inverse of root 3 by 2. It is nothing. We will get t1 as cos of 30 is root 3 by 2. Okay, so cos 30 is root 3 by 2. So cos 30 means it is pi by 6, 180 upon 6. That is seconds, pi by 6 seconds. It takes pi by 6 seconds for the particle to move from point O to point B. More further, if we will go, one more formula we are going to take. I am taking the formula for displacement. As when particle reaches at this point, what is the displacement? From displacement, I will get what is the time t2. So I know, because when it is moving from O to B, x and again more b, then it goes to 2b. So we want to know what is. So it means your x and amplitudes are same here. So we can use this formula. X is a sine of omega t, because starts from mean position, pi is 0. So here x is again 2b, because we are finding t, time t2. So when t is, we know when t is t2, your x is the thing, x is twice of b. Already it is mentioned here, if the particle is moving away from O at an instant. Okay, so here find the time required by particle to travel further distance b. So b plus b is 2b. So x we are taking it as 2b. So we are taking x as 2b. When t we are finding time, what is the time taken to move from here to here? So 2b. So here, hence we are getting x is 2b, which is amplitude also 2b we are getting from here. And then we got sine of omega. Omega is 1. We got time t is t2. So here we are having sine of t2, which is equal to 1, and t2 is equal to sine inverse of 1. Okay, so we are getting 2b upon 2b, that is sine t2. So sine inverse of 1. So what is sine inverse of 1 is t2. It is nothing. We get pi, sine 90 is 1. So we got pi by 2. So time is pi by 2 seconds in terms of pi is in terms of radian. Therefore, what is the final time is t2 minus t1. So when the particle is moving right from t1 to t2 or t2 minus t1, right from b2 to b, what is the time taken for the particle to move from b to amplitude or b to twice of b? So that is, we are having pi by 2 minus what is the time t1. T1 we got it as pi by 6. So if you are going to solve this now, we will get 6. 3 pi minus pi, we are getting an LCM, we are getting it as 2 pi by 6, and 2 pi by 6 we are getting here. Finally we are getting t2 minus t1, we are getting it as pi by 3. So pi upon 3 radian, that is pi radian upon 3 seconds. So that is the final answer. So the sum number 17. We are having the displacement of an oscillating particle is given by x is a sine omega t plus b cos omega t, where a, b and omega are constant. Here we can just see, students, that we are having this equation. It is similar to the composition of SHM. Instead of one particle, we are having two particles. In composition of SHM, we are getting this type of equation. X is, we are having sine and we are having cos. Prove that particle performs a linear SHM with amplitude a is under root of a square plus b square. We are having two methods. Let us see one method here. First, we are having in given, it is given x is a sine of omega t plus b cos of omega t. If we are going to compare with your composition of SHM, we have seen some equation we have seen in terms of x is, you know, in your composition x is r sine omega t plus alpha. So if you are having is this one r sine omega t plus delta, if we are going to compare, now this is already, and we know this is given to you, this is given, we know that, and this is nothing. X is, we are having r sine, that is sine a cos b plus cos A plus cos A sin B. This is what we are getting. If you are going to compare this with this, we are having here A and B. Okay. So here, if you are going to write this as R cos delta sin omega t plus R sin delta cos of omega t. Because we are having in composition the resultant displacement, composition of the resultant displacement is x, R is the resultant amplitude, and delta is the resultant phase difference. Then we solve this, and now when we are going to compare with, we are having what is given, x is A sin omega t plus B cos omega t. So by comparing, therefore we are going to get now this R cos delta, we are having sin omega t. So this is sin omega t we are having, and this is sin omega t. Here we are having cos of omega t, here we are having cos omega t. So when we compare sin and sin omega t, we get R cos delta, which is A, and then similarly we get R, comparing this R sin delta, squaring both the sides, squaring and adding, we get R square sin square delta plus R square cos square delta, which is A square plus B square. So R square sin square plus cos square is 1, that is A square plus B square, and here resultant amplitude R is under root of A square plus B square. According to theory we have done here, it is R we have taken, or you can take instead of R, same thing you can write this as, that is capital A is resultant amplitude is A square plus B square. This is one of the method. We are having 20 centimeter wide thin circular disc of mass 200 gram is suspended to a rigid support from a thin metallic string. We have done in the application of angular simple harmonic motion. You have already seen the diagram here. There was a rigid support, and then we are having a string, that is a metallic string, and then it is connected to the center row. We are having a disc, the rim which is there, and then center row, and then you are going to just give a small angular displacement so that it is going to twist, and then it will oscillate clockwise and anti-clockwise. It will start oscillating clockwise and anti-clockwise. So what is given to you is your twisted through 60 degree, and it will just going to perform partly, that is angular simple harmonic motion. Now what we are having here is what is given to you. You are having mass 20 centimeter wide thin circular disc. It is a 20 centimeter. So total this we are having this is 20 centimeter. So your diameter is given to you. Diameter is 20 centimeter. So how much is radius then? Radius is 10 centimeter. We can take it as radius as 0.1 meter, and then we are having mass which is there 200 grams divided by 1000. We are having 0.2 kg. Converting it to SI unit, we are having 0.1 meter radius. We are having mass, that is 0.2 kg. The string is twisted through 60 degrees. Angle made, that is angular displacement is there. So theta is 60 degree, and release. It now performs angular oscillation of time period is 1 second, t is 1 second. All this is given. Calculate the maximum restoring torque. So we are going to find restoring torque. This torque. We do the formula for torque is c theta. Let us get one by one. The solution part. torque is c theta. Theta is given, then we are going to find c, because c in terms of omega we are going to find it. So first let us find omega. We are having number 1. So what is omega? Omega is 2 pi by time period t. So it's 2 pi upon time period t is 1 second. So we are getting here omega is 2 pi radian per second. So we have to find torque. What is the torque acting on this? Next is we are finding here moment of inertia of the disk, which is given by mr square by 2. If we find moment of inertia, we can use that in relation between omega, angular frequency, I and c, torsional constant, and if we get torsional constant c, we can find torque. So I is mr square by 2, here I is m, mass is 0.2 into radius is 0.1 whole square divided by 2. So we get it as 0.2 into, here we can write this as 2 into 10 raised to minus 1, 0.9. Here 1 into 10 raised to minus 1 the whole square. It becomes square and then divided by 2. 2 and 2 will get cut. We are getting it is 1 into 10 raised to minus 3 kg meter square. Kg meter square. So this is moment of inertia 10 raised to minus 3 kg meter square. So we got moment of inertia. The next is we are getting a formula for your omega, relation of angular frequency is c upon I. Already we have derived this. We are having differential equation d square theta upon dt square plus here it is c upon I theta. We got this differential equation for angular simple harmonic motion. So when we compare this with d square theta upon dt square plus omega square theta is equal to 0, angular frequency where omega square is c upon I. So omega is root of c upon I. So here we are getting formula for relation of angular frequency for angular simple harmonic motion is c upon I, moment of inertia. So here squaring is omega square is c upon here, hence from here we can get torsional constant c, which is omega square I. On squaring both the sides, c is omega square. What is omega square? We are having is 2 pi whole square into moment of inertia. So that is I is 10 raised to minus 3. So we get 4 pi square into 10 raised to minus 3 Newton meter. And again, next is torque. Torque is c theta. Students, torque maximum is c theta. We are having c is 4 pi square into 10 raised to minus 3 Newton meter, and this is in 60 degree. So we can convert this degree into radian. 10 raised to minus 3, it is pi upon 3. We are having 4 pi cube into 10 raised to minus 3, 4 by 3. So finally 4 pi cube is approximately given in your question is 31 upon 3 10 raised to minus 3. And if you are going to solve this, you will get 0.041 Newton meter. It is 0.04133 Newton meter. So torque maximum is 0.04133 Newton meter. Sum number 23, we are having a wooden block of mass m is kept on a piston. We are having, you know what is piston basically, जो move with up and down. We are having a piston that moves, that can perform vertical vibrations. So you know basically what is piston, it is something like this. Okay, so this is the piston we are having. Is going to move up and down. We can assume the diagram to be the piston is connected to a block. So this is a block, or you can take just invert of the piston. You can have the piston in this direction also. The block is kept on this. Just the reverse piston you can take. This is the block we are having in mass m, or we can take this as a block having mass m. This piston is moving up and down, so this is one position and this is another position. We can take it as this is the highest position, we can take it as lowest position. The diagram is not there for you, but you should know that the piston is performing vertical SHM, simple harmonic motion, between two extreme position having amplitude. One is A on this side and on plus A and minus A. So vertical SHM it is performing. So basically restoring force is acting on this piston between two extreme position. So what is given to you? So wooden block is kept on that piston. Piston is moving up and down, adjustable frequency and amplitude. During vibrations, we don't want the block to leave the contact with the piston. How much maximum frequency is possible if amplitude of vibration is restricted to 25 centimeter? So the amplitude is given, A is 25 centimeter. We can write it as 2.5 meters. In this case, how much is the energy per unit mass of the block? G. So here we are going to find, first thing is we are finding your frequency N, and second thing is we are finding energy per unit mass. So when the piston is performing vertical vibration of adjustable frequency of amplitude, so restoring force acts. So restoring force always acts towards the mean position, and that is maximum. So restoring force F is acting on that force, restoring force is acting, and it is due to the weight on the block. So the block is kept, the wooden block is kept on the piston. Piston is moving up and down. So at extreme position, at the highest point, if we are going to take here, at highest point, at extreme point, here restoring force, because restoring force, the force is acting towards the center, so restoring force is maximum at the highest point. So here it is due to the weight of the block. So restoring force is maximum, and that force is also balancing the weight of the block, that is mg, F equal to mg. And what is the formula for restoring force? We are having, it is m into a, so acceleration, so mass into acceleration, so we write it as m omega square a. So force, restoring force is maximum at the highest point, and that is F, which is ma, that is m into a, we write it as ma, and that is mg, and here it is m into acceleration is omega square a. Maximum acceleration is omega square a at the highest point, that is equal to weight of the block. So m omega square a equal to mg. Now by finding omega, so what is omega square? Omega square is m and m will get cut. We are going to get g upon, we are getting amplitude. So omega square is g upon amplitude. Here we are having omega is under root of g by a. So that is 10 upon amplitude is, we are having 0.25. So 25 upon 100, that will go up. That becomes your, so that is under root of 40. So that is 2 root 10 radian per second. Frequency, so omega is 2 pi n, we know that is 2 root 10. So n approximately we will get, if you are going to put the value of square root of 10 in logbook, you'll get approximately is 1 hertz, 1 point something you'll get. So frequency is 1 hertz we are getting, so that is 1 that we are getting frequency, the maximum frequency, so that the block is not going to lose the contact with the piston. So how much maximum frequency is possible, so this is the frequency. Next is we are having your energy per unit mass. So what is the formula for energy? Is half Ka square. We have seen in linear HSC we are having half Ka square, where K is constant. And what is K? We are knowing it is m omega square, A square here, because omega square is K by m, omega is root of K by m, so K is m omega square. So energy per unit mass, if we will see, it is omega square A square upon 2, just put the value. Omega, we are putting the value as 2 pi n again, whole square, amplitude square upon 2, put all this value, 4 pi square, it is 1 square approximately into amplitude square, we are having amplitude 0.25 whole square divided by 2. So if you are going to solve this, you will get 1.25 joules energy and mass, that is per kg. So the answer is energy per unit mass of block, which is 1.25 joules per kg.